This is actually the research I'm doing. I should probably do a separate video about that, shouldn't I? Hi, my name's Zach and I'm currently completing a PhD at King's College London. I work in the biomedical engineering department with a group of amazing people that all specialise in using neuroimaging techniques to study epilepsy. Epileptic seizures affect 70 million people worldwide, and about a third of these people have seizures that medications just don't fully stop. And this creates the need for research projects exploring alternative approaches to reduce how often people have seizures. This is actually the research that I do. Let's get into it. Epilepsy is a neurological condition where there's a spontaneous, uncontrolled burst of electrical activity in the brain that causes seizures. And there are many different types of epileptic seizures, and the one you're probably most familiar with is the Tonic-Clonic seizure, where muscles become stiff and limbs jerk quickly and rhythmically. But there are also other very common types of seizures. I made a whole video on epilepsy, linked here. Epilepsy affects the lives of millions of people, so there's a huge drive in research to understand underlying causes better to find more effective treatments. I work trying to make a tiny contribution to the tidal wave of this research happening around the world. So look at this. I'm playing this game, but I'm not using keys or a controller to play it. I'm using my own sweat levels. These sensors here and here are measuring something called galvanic skin response. Galvanic skin response is a measure of sweat levels on a small but precise scale. The amount that you sweat, your galvanic skin response, can be used as a measurement of your emotional arousal, which is connected to your nervous system and brain, the place where abnormal electrical activity causes seizures. This game takes an input of sweat levels from sensors on someone's fingers and uses those sweat levels to control the game. If the person's sweat response goes up, this is reflected on the screen for the person to see. With practice, playing this game can, weirdly, allow a person to eventually learn to control their sweat response to go up or down. Even more weirdly, this kind of training across a few weeks has been shown in some studies to actually reduce epileptic seizure frequency. And it begs the question of, how the hell could this possibly work? So I developed this game with a mega talented undergrad, and I'm using it to train people to increase or decrease how much they sweat. And then once trained, the research can really begin. First, we place this on them. This is called EEG, and it measures the electricity in the brain. We can then put them inside an MRI scanner, which takes pictures of their brain using magnets. Whilst they're lying in the MRI scanner with the EEG on their head, we get them to use the training that they just had to increase and decrease their sweat response. The EEG and MRI then tell us loads of information about how their brains are changing as their sweat response goes up and down. We can then try to figure out how this changes the brain and why it might be reducing how epileptic a brain is. So we're testing a theory that abnormal connectivity in the brain, which can cause seizures in people with epilepsy, can be reduced by increasing galvanic skin response. To investigate this, we asked participants to increase their sweat response while they are having an fMRI brain scan. By doing this, in real time, we can observe the changes in brain connectivity as people increase their sweat response. We conduct this study in both healthy individuals and people with epilepsy to compare how an increase in sweat response affects their brain. This is called neuromodulation of epileptogenicity by autonomic training. The NEAT project. It's pretty neat. Now this is important. I find the research I'm doing fascinating, and it may sound glamorous, but it's important you know my day-to-day is this, and lots of this. But it's great, and the painfully slow incremental progress is really rewarding. I get to spend each day learning about how the brain works and get paid to do so. And there's the hope that I will eventually be able to make a small contribution to this very interesting field. I'll also just clarify now that I'm not a medical doctor and I'm not trained or qualified to diagnose or treat individuals with epilepsy. Neurologists diagnose patients, and then I scan their brains and analyze the data to better understand the abnormal activity that causes people to have seizures. In the world of neuroimaging research, there's a big collaboration between the neuroscientists and the clinicians, the physicists, the engineers, the radiographers, and everyone plays on the same team to advance human understanding of diseases. How did I arrive here? It was a bit unconventional. I went to Leeds University to study neuroscience, and after graduating I went off to drama school and trained in musical theatre performance for a year. And then I went to work in a company in London for a couple of years where I got into the world of coding, and then I began my PhD at KCL. Completing a PhD is challenging for a few reasons. One challenge is being self-led. Like, there's a team around you and a supervisor to guide you, but really it's down to me to figure out what I need to do each day to advance my research. Should I spend the day writing up results, coding some new funky analysis, organising time slots for patients and healthy controls for my study, attending a course to improve my knowledge, or just kind of sit on the sofa and cry because absolutely nothing's working? How I choose to maximise my time is fully up to me, which is both a challenge and a privilege. Anyways, thank you so much for watching. Let me know if you have any questions and I'll see you in the next one.
You need a haircut, bro.